Dear students, in this video you will see about electric motors, module 5, syllabus, introduction, types of synchronous motors and principle of working of three-phase synchronous motors. First we will see module 5 syllabus. So in module 5 you have two parts: synchronous motors, other motors. In synchronous motors you will learn about principle of operation, phasor diagram, torque and torque angle, Blundell diagram, effect of change in load, effect of change in excitation, V and inverted V curves, synchronous condenser, hunting and damping, method of starting synchronous motors and other motors. In this you will learn about construction and operation of universal motors, AC servo motor, linear induction motor and stepper motor. So this is your module 5 electric motors syllabus. First, coming to the introduction part. So in three-phase supply is given to stator of the three-phase alternator. So alternator is a AC generator. So we can also called synchronous generator. So which consisting of three-phase stator winding. So here we are giving supply to the three-phase stator winding. So it can work as a motor. So as it is driven at synchronous speed, it is called synchronous generator. Synchronous speed means constant speed. If it is runs at constant speed, then the machine we are calling as a synchronous generator. So if alternator is runs as a motor, it will rotate at synchronous speed. Such device which converts and electrical energy into mechanical energy. The device which convert mechanical energy into electrical energy, then the machine is called generator. The device which converts electrical energy into mechanical energy, then the device is called motor. So electrical energy into mechanical energy is motor. Mechanical energy into electrical energy is conversion device is called generator. Okay. So these devices which runs at synchronous speed, then the device is called synchronous machine. The motor which runs at synchronous speed or motor is runs at constant speed, then the device is called synchronous motor. The device which runs at synchronous speed, generator, suppose if a generator is runs at constant speed or synchronous speed, then the generator is called synchronous generator. Okay. Synchronous motor works only at synchronous speed. So synchronous motor is works at only synchronous speed means constant speed. Okay. So it cannot work at speed other than the synchronous speed. So it less than the synchronous speed, more than the synchronous speed, it will not work. So the speed is constant irrespective of load. If you change any type of load, so a 20% load, 50% load, 70% load, 100% load, if you change any type of load, then the speed will not change. So then the motor is called synchronous motor. Okay. The synchronous motor, the speed is always constant irrespective of load. Okay. Now, so types. Coming to the types, so these synchronous motors are classified into two types: three-phase synchronous motor and single-phase synchronous motor. So single-phase synchronous motor further classified as reluctance motor and hysteresis motor. So this is a special type of motor. So we can call it as a special type of motors. The three-phase synchronous motor works on the concept of rotating magnetic field, RMF. Rotating magnetic field, simply we can call it as a RMF, rotating magnetic field. The field produced by stationary three-phase winding, the stator consisting of stationary winding, that is stator winding or armature winding. So, which will produce the field. So, which rotates in space is called rotating magnetic field. The speed is always synchronous and is given by synchronous speed we are denoting with ns. Ns is equal to 120 F by P, where P is equal to number of poles for which winding is wound, and F is equal to frequency of the supply. Okay. So, here synchronous speed we are measuring in terms of revolutions per minute RPM, revolutions per minute, or revolutions per second RPS. Okay. Now, we will come into the principle of working of three-phase synchronous motor. So, it works on the magnetic locking. So, magnetic locking diagram is there. So, here force attraction and force repulsion. So, we can see in this diagram. So, here like poles will repel each other and unlike poles will attract each other. Based on that concept, so this synchronous motor will work. So, the principle is magnetic locking. When the two unlike poles brought near to each other, so two unlike poles each other, what will happen? Attraction will happen. The magnetics are strong. There is exist a tremendous force of attraction. The more force will be created between two unlike poles. Such condition, the magnetics are said to be magnetically locked. So, unlike poles, if we take each other, if you nearby side by side, if you take, or nearby near, if you take, so magnetic locking property will happen. Okay. Now, one of the two magnets is rotated. So, if one of the two magnets is rotated, the other also rotates in the same direction. So, one magnetic if you rotate, in other magnetic also will rotate in the same direction. So, you can see in this figure 1. So, one magnetic if you rotate, other magnetic already it will there in magnetic locking. So, other magnetic also will rotate. Okay. So, same direction. So, which is the same speed due to the force of attraction. So, magnetic locking principle is there, attraction is there. So, that it will rotate in same direction. So, due to magnetic locking condition, the principle is shown symmetrically in this figure. Okay. So, consider three-phase synchronous motor. So, which is having two poles. The two pole means the RPM synchronous speed will be 3000 RPM. The two magnets fields are produced in the synchronous motor by existing both the windings. So, stator and rotor. So, two pole synchronous motor we are considering. So, force will be attraction, force or magnetic field will be attracted between those two poles existing both the windings, stator and rotor. So, with three phase AC supply and DC supply respectively. So, when the three phase winding is excited by three phase AC supply, the flux is produced, and three phase winding is always rotating type. So, which is already discussed in the previous slide. So, previously magnetic locking concept, how we have discussed one magnetic if you rotate, other magnetic also will rotate like. So, here also will be rotate. So, magnetic flux rotates in space at the synchronous speed. So, this magnetic field is called rotating magnetic field. See here RMF, rotating magnetic field, which creates effect similar to physical rotation of the magnets in space with synchronous speed. So, physical rotation, if you rotates like here also in three phase synchronous machine also will rotate. The stator of the synchronous motor produce a one magnet, a magnetic flux, so which is rotating as synchronous speed. So, here we can also see when two pole synchronous motor, what is the synchronous speed? So synchronous speed formula is ns is equal to 120 f by p, where p is equal to number of poles, f is equal to supply frequency. So we are measuring in terms of hertz. So we are considering 2 poles synchronous generator, 50 Hz supply frequency, then the speed will be equal to 3000 rpm. So this effect is similar to physical rotation of the 2 poles. So the speed is ns, speed of ns is equal to rpm. For simplicity of understanding, let us assume that stator poles are n1 and n1 and s1. The synchronous speed we are considering as a ns. The direction of rotation of the rotating magnetic field is says in clockwise direction. So here when the field winding on the rotor is excited by DC supply, also produce the 2 pole, assuming rotor construction to be 2 pole silent pole type. So now we are seeing new positions N2 and S2. So new positions of the poles N2 and S2. Previously we have considered N1 and S1. So one magnetic is rotates at synchronous speed N1 and S1, while stator starts while at the start rotor is stationary. The second magnetic is stationary, having poles N2 and S2. So if you keep unlike poles N1, S2 and S1, N2 are near. So there will be a magnetic philosophy, magnetic locking principle. It will be established between N1, S2 and S1 and N2. So this magnetic locking property will be develops between unlike poles each other. The stator poles are rotates due to magnetic locking. Rotor will also rotates in the same direction as stator poles. Okay. So the direction of rotating magnetic field with the same speed ns. So this is the principle, magnetic locking principle. So synchronous motor will be operate. Okay. So in next video we will see about why synchronous motor is not self starting and phasor diagram of synchronous motor. Okay. Thank you everyone.